So Module 3 deals with the idea of projectile motion. So projectile motion just happens when gravity is the only force acting on the object. And we haven't dealt with forces yet, but we have experienced this already. So we've dealt with falling objects in the last module. And then when they're in the air, the only thing acting on the object is the force of gravity. That's why it has an acceleration downward as a result of an acceleration downward, a value of g. So we already have an idea of projectile motion, except that that was in one dimension. So one dimension is just falling objects. The problems we dealt with were objects that were either going vertically straight up or coming down vertically. So they were along a straight line. Now in this module, we're going to extend it. So we're going to extend it into 2 dimensions. And so the only thing that's going to be different is now we don't have just motion in 1 dimension, we have motion in 2 dimensions. So it's going to be moving in the x and the y direction. And so the path of the projectile, the path of the object, is going to follow a curved arced path. In physics terms, we call the path that the object takes the trajectory, and that trajectory of the object, projectile motion, is going to follow a parabolic path. So it's going to follow this curved path. So we just watched a video of the dimes being pushed off the table and then dropped from the table at the same time. And so one is being hit so that it has a horizontal velocity, but it doesn't have any velocity in the y direction. Likewise, the other dime doesn't have any horizontal velocity, it's just being dropped straight down. But they're both starting from rest. They don't have a vertical velocity to start. So we've dealt with this one. The one that's being dropped straight down, we've dealt with problems exactly like this. So we can draw off of our experience from that and apply it to 2 dimensions. So what happens with this first one? Well, for a motion diagram, it's starting from rest, so it's going to have a velocity downwards, and then we know that the acceleration due to gravity is pointing downwards, so velocity and acceleration are going to be in the same direction. When that's the case, the particle speeds up. So here, we expect a little bigger and then even faster. So it just drops straight down. We've dealt with problems like this before. What we haven't done is what happens, say, for 2 dimensions. So for the other dime, it's going to follow that parabolic trajectory till it hits the ground. So the question is, what's the difference between the two and what's the same between the two? If you watch closely in the video, you might have seen that the dimes hit the ground at the same time. But how can that be? One has a velocity at the start and the other one's just being dropped from rest. How can they both hit the ground at the same time? And so that's where this diagram comes into play. So for projectile motion, motion in both the X and Y direction, you split it up into two different sets of directions. So you only deal with the Y component, and then you only deal with the X component. You can break it up. You can separate it into things we know how to do. We know how to deal with an object falling straight down. That is this Y direction. And then we know how to deal with motion in one dimension. So then we can deal with motion in the X direction. For projectile motion, there is no acceleration in the X direction. And this is key. Remember what our definition was of what projectile motion is. Projectile motion means that gravity is the only force acting on the object. That means we only have acceleration in the Y direction as a result of gravity. No other forces are acting. There's nothing else happening to the object, so we know that there's nothing causing the motion in the X direction to accelerate. So we just have motion in a constant velocity in the X direction. And so what this diagram is showing is that you just deal with the Y direction. You define what the speed is, what the position is, and then you deal with the X direction separately. Now the question you may have is, how are they linked? They have to be connected, because all we're doing is we're splitting up what this projectile motion is. We're splitting it up and only concerned with what's happening in the Y direction. What's happening in the Y direction? And then what's happening in the X direction? Since we're just splitting it up, you have to remember that this motion is all the same motion. How we're dealing it with it in the Y direction and the X direction, it doesn't matter. It's still the same motion. So what must be true about them? Well, they must have the same time. This is one object that's moving through the air. It's moving in both the X and Y direction at the same exact time. And so we can now go back to our example here and explain why is it that the pennies fall and hit the ground at the same time. They're both starting from rest at the same height, and they both leave at the same time. So if we look at the Y direction, they both have the same components in the Y direction. They're both starting from rest in the Y direction. They're going from the same height, so they must hit the ground at the same time because they have the same acceleration. The only difference is that this second one has a component in the X direction. So since they have the same component in the Y direction, they fall at the same time. The only difference is one travels further because it has a component in the X direction. So its range is different, how far it travels in the X direction. So we're going to get a lot more practice with these concepts as we go through this module. But you always have to remember, split projectile motion up into dealing with it in just the Y direction and then dealing with it in just the X direction. That's the key. And if it helps, always come back to this diagram, because I think it kind of helps visualize it, where you're splitting up each motion. It's independent of each other. What happens in the Y and what happens in the X are independent of each other. They don't care about each other. And so here, like always, are the learning objectives for this module. I'm going to point out a few big ones that we're going to be dealing with graphs. So again, much like Module 1 and Module 2, we're just trying to give you a lot of practice and give you feedback on how to deal with graphs, how to be able to move from a description of motion to a graph, and from a graph to describing the motion of that graph. Conceptual questions are always big. And then the big part here is we're going to be analyzing problems. We're going to be using the problem-solving framework. And this is why we wanted you to have practice with that problem-solving framework, because we're now making things a little more complicated. We're adding an extra dimension to these problems. So the problem-solving framework is going to help organize this problem and keep this y motion and this x motion separate when you're trying to solve the problem.